those who are online, are you able to hear me?
Yes, sir.
Yes, sir.
Are you able to see my screen also?
Yes, sir.
Perfect. We'll get started. Right. So did you guys solve few problems in the previous class? Sir helped you with few problems. Can I check what was taught? The inclined plate one. Okay. Yeah. So in the previous class, this was a problem with which we stopped, right? So I think you're new, no? Try to understand. Wherever you have doubt, you can ask. The lab iPad, right? So do you guys remember the concept? So what did I tell you? When you take an object and place it on the inclined surface, then what are all the points that we need to consider, keep in our mind? When you draw the free body diagram, what happens? Mg is going to be downwards. Mg can be resolved into two perpendicular components. What are the two components? One is going to be Mg cos theta, right? So it is going to be Mg cos theta and Mg sin theta, right? Then the normal force is going to be perpendicular to the surface itself, right? So based on that, if the surface is considered to be smooth, we calculated what is the acceleration with which it is going to slide down, and the acceleration value came out to be A is equal to G sin theta, right? So having this as an extension, so having this as an extension, let's proceed with the next set of problems. Okay. So what I'm going to do is, I'm going to extend this. Observe. There is an inclined plane. Yeah. So there is an inclined plane on top of which there is a block of mass m that is placed. Right. Now, this block, let's say this is M1. Okay. This block is going to be connected to another block through a pulley. Of mass M2. Okay. It is going to be connected to mass M2, where this pulley is going to be massless and frictionless. Right. So one more thing is, this pulley is not going to rotate also. It is just being as a support on which the object is going to move. Right. Now my question is, if the system starts accelerating in this direction, if the system is starting to accelerate in this direction, what is going to be the acceleration of M1 and acceleration of M2? Okay. Plus M2. G sin theta is acceleration, M2 is mass. How can you add two physical quantities with different dimensions? How to proceed? So how we can do this is, observe. Okay. Now, if you take M1 alone, right? If you take M1 to be placed here, then M1G is acting downwards, right? So if I take this angle to be theta, now what is this going to be? This will be M1G cos theta, and this will be M1G sin theta, and there is going to be a normal force acting in this direction, accepted, right? So apart from this, if you need to observe that M1 is connected to a string, right? M1 is connected to a string, hence there will be a tension also acting in this direction. Okay, there will be a tension which is acting in this direction in such a way that the tension here and here will be the same. Why is it so? Because there is only one string. Number of strings is equal to number of tensions in the problem, right? So I hope this block diagram is clear. And in which direction is the system accelerating? This one. Now, if you observe, what are we supposed to do? You need to take the basic coordinate system. So for this particular system, what is going to be the coordinate axis? It will be taken like this, right? It will be taken in this way, so that I can take this direction to be positive, this to be negative, this to be positive, this to be negative. Why did I do so? Because this direction I took it as positive, because whatever is the direction of acceleration, I'll take it as positive. Okay. So tell me how to frame the equation. M1G sin theta, M1G sin theta should be greater than T. So M1G sin theta minus T is equal to M1A. Is it right? So according to Newton's second law, the net force acting in this direction should be equal to mass into acceleration. What is the net force? M1G sin theta minus T is equal to M1A. Right. So this will be the first equation. Now for the second equation, I need to draw the second free body diagram. If you observe, M2G is downward, tension is upward, right? So because in this case, if the tension is acting to the right, here the tension will act upwards, because at the ends of the spring, the tension should be in the opposite direction. So all that you need to do is you look at this one, assume that it is stretched. Okay. So actually, how is it looking? It is looking in this way, right? So it is going like this, and this part is hanging, right? So if the tension here is upward, right? If you stretch and see it like this, the tension here is in this direction. So what will be the direction of tension here? Leftward. So when I put it as leftward, so here it is leftward, I'm bending it like that, visualize it. So this side it will be in the upward direction. So that is what is happening here. So it will be upward. Now the next question is, in this direction, if the system is accelerating, how should I write the mathematical equation in this case? Which one is dominating? T minus M2G should be equal to M2A. T minus M2G should be equal to M2 into A. Now, what you can do is when you add these two equations, okay, when you add these two equations, you will get M1 sin theta minus M2 into G is equal to M1 plus M2 into A. So what will be the acceleration? M1 sin theta minus M2 into G, the whole divided by M1 plus M2. So this is going to be the value. This is the acceleration of whom? Acceleration of the whole system. Is the point clear? Yeah, just make a note of it. check it. Shall I proceed? Yeah. Right. I'll slightly extend this concept. Okay. Listen. See, the next question is, let's say there are two blocks of mass. Okay, I'll take M1 and M2 lying on the inclined surface, and I'll take this angle to be theta. Okay, what am I doing? I'm taking this angle to be theta. Again, this system is connected through a pulley to another mass of mass M3, of value M3. In this scenario, what is happening is M3 has sufficient mass in such a way that the system is going to accelerate in this direction. Okay, now our job is to find what is the acceleration of the system. Again, the same conditions are applicable. What is it? The strings are inextensible and they are massless. Similar is the case with respect to the pulley also. Is that point clear? Can you try it out? You be relaxed. You relax. Already there. Video already இருக்கு. அது பார்த்தா புரியும். Those are online. Are you trying?
Yes, sir.
Not even one is correct. Everybody is wrong. G sin theta minus T is dimensionally wrong. You cannot, G sin theta is acceleration, tension is force. You cannot add two physical quantities of different nature. You cannot add acceleration to force. The way you drew it perpendicular to the surface. You drew perpendicular to the horizontal. Mg cos theta. That is wrong. It must be perpendicular to the surface. It is not perpendicular. It is not parallel. It's just horizontal the way you drew it. That is wrong. Yours is completely wrong. What was the mistake in your carton? You are trying to exactly copy the above problem. In a mala problem, you didn't write one thing. You're just blindly following the previous problem. That's not how it is going to work. So I want you to concentrate. Listen to me. Okay. Everywhere it will get cancelled on. So thing is, when you draw the free body diagram of M1, no, what is this? This force is M1G. How is it resolved? What component is this? It is M1G sin theta. But here you drew it wrong, no? So it is actually M1G sin theta. I told you many times. Because if theta is taken with respect to the horizontal, then this will be M1G cos theta. If it is taken with respect to vertical, then this will become sin theta. Now I told you it will get reversed. They're complementary of each other. As a result of which, this will be how much? M1G cos theta. So this is the first change that you need to understand. And when this system is moving in this direction, there is a tension acting here. Let me call this as T1. So this is the first string, this is the second string according to me. So it is T1 upwards and normal force in this direction. So let me call this as N1 itself, right? So T1 minus M1G cos theta should be equal to M1 into A. See, framing this equation is very simple. By now you should have understood, right? In a similar way, if I take the mass M2 here, for mass M2, observe, if the tension here is acting in this direction, if I call this as T1, the tension here should be in the opposite direction, which is T2. So with respect to M2, in this direction, what are all the forces acting? It is M2G cos theta. Along with that, there is T1 also acting. So there are two forces, that is why two arrow marks. Okay. So this will be downward, it will be M2G, and this is going to be M2G sin theta. And how much is this force going to be? It will be N2. It will be N2. Similarly, what about M3? M3G is downward, tension is upward. So how much is the tension going to be? It will be T2. There is something missing in this diagram. The other end of M2 is connected to a string. So here the tension will be in this direction, T2. This tension is what is pulling it upward. Did you understand the free body diagrams? Now the question is, we need to frame the equations for each. So for this, frame the equation, tell me. T2 minus M2G cos theta. So it is actually T2 minus of M2G cos theta plus T1. So the difference of these two forces, because M2G cos theta plus T1 will be the force in this direction. T2 will be the force in the upward direction. This must be equal to how much? This must be equal to M2 into A. Is the point clear? So what is the equation for this? It is moving downward. Can you tell me? Which is dominating among these two? Acceleration will tell that. M3G is greater than T2. So M3G minus T2 is equal to M3 into A. Is the point clear? Right? So you need to solve these three equations to get the final answer. So what you're going to do is, what we need to do is we need to add all the equations. When you add all the equation, T1 and T1 will get cancelled. T2 and T2 will get cancelled. So what is that you're going to get throughout? M3G. So M3G is positive minus of M1G cos theta plus M2G cos theta should be equal to M1 plus M2 plus M3 into A. So what will be the acceleration? A will be equal to G into M3 minus of M1 cos theta plus M2 cos theta, the whole divided by M1 plus M2 plus M3. So this is going to be the final value. Okay. Is the point clear? Did you understand how to break it into free body diagrams? Right? So just make a note of this. Shall I proceed? Okay. Right. So these are all some problems based on free body diagram. Now we'll go to the next important concept in this chapter, which is called as impulse of a force. Okay, write down the heading as impulse of a force. Okay. See, generally, if you go back to the definition of or statement of Newton's second law, what does it state? That force is equal to rate of change of linear momentum. So what is force? Force is going to be rate of change of linear momentum. So to put it simple, the force that you are applying on an object is going to do what? So force you apply on an object will actually change the momentum of the system. So what is going to happen? Its speed is going to change, meaning if the object is at rest, it will go into motion. If the object is already moving with uniform velocity, then what will happen? It will try to come to rest. So these are the two objectives with which we are going to apply force, right? So in both the cases, what is the important parameter we are changing? It is a speed. So 0 to some speed or some speed to 0, right? So when that speed is multiplied with mass, what is it going to give you? It is going to give you momentum, right? So whenever there is a question asking you, what does momentum do? Momentum basically changes the, sorry, what does a force do? Force changes the momentum of the system. So that is why if you look at the topic here, when I talk about impulse of a force, so this also something that has to be done with the linear momentum concept. So try to understand. So impulse is the total effect of a large force. So what will you do is you will apply a large force for what? For a short time interval. Right? The best example is, let's say you're playing carrom board. Right? You have a striker. So what do you do to that striker? Follow me. Go wash your face. Yeah. Okay. So what was I telling? Okay. So when you play carrom board, right? So what do? You have a striker. Are you going to take the striker and push it along and go and hit the coin? You don't do that, right? So there is a line. You just keep it here. Just apply the force. But what are you doing? You apply a large amount of force for a smaller duration. Are you able to understand what I'm trying to say? See, applying force means if I take this object, right? If I take this object, if I try to apply the force continuously, right? I'm changing the momentum. See, it is red at rest, changing the momentum. But what I can do to the same thing is I can give it an impulse also. If I hit it, right, with sufficient amount of force so that it is able to move the same distance by like how it was able to be achieved by applying the force, right? Then you call that large amount of force that you apply for a short duration of time. With what objective? With an objective to create a change in momentum. Right? Why is an impulse applied in the first place? Large force is applied for a short duration. That is what is called as impulse. And that impulse will achieve what task? It will change the momentum. Are you able to understand? So impulse is what this is. Right? Total effect of a large force which acts for a short time to produce a finite change in momentum. Right? This is the definition for us to understand or visualize what momentum is. So I hope you understood in the carrom board example also what you're actually doing to the striker. Are you giving it force or impulse? You're actually giving it impulse or force. You're not continuously moving it. Right? So having said that, we need to have a mathematical definition because we are trying to relate all the terms which are measurable. When I talk about force, it is measurable. When I talk about time, it is measurable. And when I talk about momentum also, it is measurable. So for measurable quantities, we need to give a quantifiable equation. So that is given by this definition. So how is mathematically impulse defined as? It is defined as the product of force and the time for which it acts on that object. Right? And is equal to the total change in momentum. So that's what the definition says. Actually, the simplest definition is impulse is basically the product of the large amount of force that you apply for a shorter duration. So F into T is what is impulse. But that mathematically, that F into T is mathematically also going to be equal to whom? It is also going to be equal to the total change in momentum. So let's see why it is so. So look at the mathematical expression. Impulse is equal to force into time duration. That is also equal to total change in momentum. But why? Let's try to understand that. For that, listen to this. See, impulse is generally represented by the symbol J. J. So, and it is a vector quantity. Why it is vector is because impulse is equal to vector quantity into scalar quantity. It is going to be a vector. Okay. So, if I write J is equal to F into T, right? Generally, when I talk about time duration, no, you will not write it as T, rather you will write it as delta T. Because it's a very small duration. Maybe it is 0.1 seconds, 0.01 seconds. Right? Even when you think of that striker example, you're applying a force, but you're not exactly applying it for 0 seconds. You're applying it for some 0.1, 0.001 seconds till you have the contact with the striker. After that, it's job. It keeps on going, right? So F into this delta T represents the time duration. Is that clear? But what is F according to Newton's second law? It is the rate of change of linear momentum. See, mass into acceleration is derived from this expression. So basically, it is a rate of change of linear momentum into delta T. So delta T and delta T will get cancelled. Answer will be delta P. What is delta P? It is a change in linear momentum. That's what is given here. So what did we start with? Impulse is equal to force into time duration. Right? After substituting force as delta P by delta T and delta T got cancelled. So mathematically, it is saying that impulse is equal to the change in momentum. Makes sense? Right. So having said that, what should be the unit of impulse? So what should be the unit of it? What should be the SI unit of impulse? It is going to be whatever momentum takes. So momentum is measured in kilogram meter per second because momentum is mass into velocity. So kilogram meter per second. So SI unit can be kilogram meter per second. But since we are using the word impulse of force, right, what I'm going to do is observe this. I'll multiply and divide it with time. That is second. If I do that, kilogram meter per second square into second. So what is this kilogram meter per second square? It is what is Newton, and this is second. This is one way of understanding. Or you know that impulse is force into time duration. Force is measured in Newton and time duration is measured in second. So Newton second is also a unit for impulse. Are you able to understand this concept? Right? It can either be written in terms of kilogram meter per second because it is a change in momentum, or it can also be written as Newton into second because it is a product of force and time duration. Is the point clear? Right? So these are all the important points that are related to impulse. And I also told you this point, you need to make a note of it, that impulse is going to be a vector quantity. Right? So you can just make a note of it. Is the point clear? Done? Shall I proceed? Yeah. Now listen to this. See, thing is, how is impulse written as? It is written as force into delta T. You need the change in time, right? So this is the mathematical expression. But we have to understand a fact, like how this can be understood with the help of a graph. So whenever you try to draw a graph, you have the x-axis and the y-axis. So generally, if you observe, the x-axis is independent axis and y-axis is the dependent axis. If I observe the quantity here, what are the two quantities on which the impulse is dependent on? Force and time. So among these two, which one is treated as independent and which one is dependent? Time is independent. It doesn't depend on anything, right? So time should be taken on x-axis and force should be taken on y-axis. Is that point clear? So when you talk about the impulse of force, majorly when you're trying to draw the force acting with respect to time, in that small duration, right, in the duration of the delta t, you can either apply the force F to be a constant force or it can be a variable force. Are you able to understand what I'm saying? Meaning in that 0.01 seconds, for instance, from 0th second till the end of 0.01 second, you could have completely continuously applied 5 Newton of force. Okay. Let's take this example. Let's say between 0 to 0.01 seconds. So what is the time duration? It is 0.01 second. So at 0th second, you started applying 5 Newton of force. At 0.01 seconds also, you applied the same 5 Newton force. And in between also, you applied the same 5 Newton force. So that kind of a force is said to be a constant force throughout the time interval. Right? If that kind of a force is existing, how is that going to look with respect to graph? When y-axis is a constant, how will it look with respect to the x-axis? It will be a line parallel to x-axis. So this is that so-called 0th second. That is the initial time. So here I took as an example of 0 to 0 point. It can happen, see, for the same time interval, I can take between 0.01 to 0.02 also. What is the time interval? Still 0.01. So it can be between any time interval, but of the same duration. So that is T1. From T1 to T2, what did you do? You kept the force to be constant. So basically, in physics, right? If you have a physical quantity, which is the product of the quantity on the y-axis and the quantity on the x-axis, then this quantity can be found by calculating the area under this graph. Right? Meaning, if I calculate this area, if somebody gives you a force and a time graph, and they ask you to calculate the time under that between this time interval, between a specific time interval, what are they indirectly asking you? They're actually asking you, area is okay, area is a mathematical term, but area gives impulse. So to put it simple, impulse in a force time graph is going to be what? Area under it. Makes sense? Right? This is how the impulse will be calculated when the force is, what kind of a force did you take into consideration? You took the constant force into consideration, but not necessary that every time you should have only a constant force. So there is a possibility where the force can be a variable also. Suppose the force is variable, then what will happen is between the time interval itself, it will change like this and it might come back to the same point. It can be any way. Right? Now, if you need to calculate this area, what does this area give you? It will give you the same impulse. But the only difference is, the way it is easier to handle things. Here it is easier to handle things because it's a regular shape. It's a rectangle. You're just going to multiply the length and the breadth. You're done. Whereas here you cannot do that. So for that, what will happen is you will use this formula J is equal to, observe this, F external, and instead of delta T, right, wherever you have variable quantities, you need to use dt, which is the differential coefficient. So F external into dt, but this is not the total impulse. You will get the total impulse by performing this operation of integration between which limits? Between T1 to T2. So this is going to be the mathematical expression for the same impulse under what scenario? When the force is variable. And the force is variable. Is that point here? Right? So these two are the important expressions you need to remember. And one more important takeaway from this concept is area under a force time graph will always give us impulse, irrespective of whether you're going to talk about a constant force or a variable force. So I hope area under what graph? Area under the. So whenever you write the graph name, right, you should write it in such a way that the first will be variable, second will be independent variable. First is dependent variable, second is the independent variable, right? So you call it as FT. So area under FT graph is going to give us impulse. Clear? So just make a note of. Those who are online are able to understand.
Yes, sir.
Yes, sir.
Okay. Shall I proceed? So listen. The question is, a batsman hits a ball straight in the direction of the bowler without changing its initial speed of 12 meters per second. If the mass of the ball is 0.15 kilogram, determine the impulse imparted to the ball. So how is it happening? Okay, let's take this as the bat. Okay. So how is a batsman hitting it? So when is it possible? When can the ball go straight in the direction in which it approached? See, when you hold it like this, right? If you're going to bend it at a certain angle, right? You're going to bend it at a certain angle. Will it be able to go back in the same direction? See, for example, if the ball is coming in this direction, right? If the ball is coming in a specific direction, will it be able to travel back along the same line along which it came? Why? Because when I bend it, what am I trying to do? I'm trying to change its direction. But if the ball has to travel back in the same direction, let's say the ball is coming in this direction, if it has to go, then the bat has to be kept exactly perpendicular to the direction of the ball. Only then it will be able to go back. Are you able to understand? So it should not be an oblique collision. It should not bend like this. Rather, it should be held like this. It should be exactly perpendicular to the direction of the ball. So having said that, what can we do? Let's try to visualize it. Let's say this is the bat, the surface of the bat across which the ball is approaching. So the ball is approaching in such a way, it is with what speed? So it has a speed of 12 meters per second. So since they use the word speed, it is very clear. It is going to be constant. It is a magnitude of the velocity. With this speed, it is going to go and hit the bat. Am I clear till this point? Right. So this is happening before the collision. After collision, what is happening? So he hits back a ball straight in the direction of the bowler. So bowler obviously is here. So in the direction of bowler means the ball should go in this direction, right? Without changing its initial speed, means the rebound speed is also 12 meters per second. Are you able to visualize this point? Right. Now the question is, There is some mass the ball has. What is it? It is 0.15 kilogram. Now determine the impulse imparted to the ball. So all that we need to do is write the formula for impulse. So what is the formula for impulse? Impulse is equal to force into duration. But the challenge here is there is no force, there is no time. But you have another expression also. What is it? It is a change in momentum. It is the change in momentum. Here, I'm using the word momentum again and again, but you have to remember it is linear momentum. So what is the change in linear momentum? It is basically final momentum minus the initial momentum. Am I clear? So what is going to be the final momentum? But here you need to be careful with one thing. What is the initial momentum? I'll tell you what is the common mistake being done. First, tell me what is the answer for this. What is the initial momentum of the system? Tell me the magnitude. Mass into velocity. Mass is 0.15, no? So 0.15 into 12 is how much? 15 into 12 is 180. So how much will it be? It will be 1.8. Right? It is 1.8 Newton second or kilogram meter per second. It is 1.8 Newton second. What about the impulse here? Sorry, momentum here. This is also going to be 1.8 Newton second. Accepted. I'm going to apply the same formula M into V. So when I write final minus initial momentum, what will the answer come out as? 0, right? That is a common mistake we do. The answer is not 0 actually. Because momentum has direction. We always start thinking only in terms of the magnitude, but we forget about the direction. So this is where we need to be careful and assign a proper direction to it. If you want to take the right side as positive, then leftward is going to be negative. So since I'm taking right side as positive, final momentum is positive. What is the final momentum value? It is 1.8 minus 1.8. Did you understand why this minus came? It is because of the direction and this minus is because of the formula. So what is it going to be? It is going to give you the answer as 3.6 Newton second. This should be the answer. It is not 0. If it comes in MCQ, the first option that they'll give you 0 and they'll confuse you, you will just put tick there and go. Don't do that mistake. Whenever there is a question of rebounding, right? Whenever there is a question of rebounding, especially with the same velocity, the momentum will always get doubled. The momentum is going to get doubled because 1.8 is the initial value. It is getting doubled, it is 3.6. Is the point clear? So that will be the answer. Done? Shall I proceed? So try this. Oh, there is no time. 1 minute. The question seems incomplete. 1 minute. This is a question. Make a note of it. Keep solving it. A cricket ball of mass 150 gram moving with a velocity of 15 meter per second is brought to rest by a player in 0.05 second. Calculate the impulse and the average force exerted by the player. What is the impulse? So in this problem, you have mass, velocity, and time. Calculate the impulse and the average force exerted by the player. For impulse, what will you use? Will you use time? Can you use time in this problem? Why? But why can't you use, since time is there, why can't you use the formula of force into time? Because force is not given, no? How do you know? So instead, if they give you mass and velocity, indirectly what is given to you? So remember, throughout physics or throughout science, wherever an object's mass and velocity are given, two important parameters are given to you. One is linear momentum and the second is kinetic energy. Because both the formulae will depend only on mass and velocity. Am I clear? So anywhere they give you mass and velocity, they give you momentum and what quantity? Kinetic energy. Never forget that. Okay. So having said that, how are we supposed to solve this problem? Indirectly, what have they given us? They have already given us linear momentum. So they have given the initial linear momentum or final linear momentum? Initial. Because what is the final momentum? Why is it 0? Because your is brought to rest. So you know what is the final momentum? What is the initial momentum? Apply the formula, that will be the answer. So 0.15 into 15. 2.25. So what is the answer? 2 point. So you cannot say negative or positive here because we don't know anything about the direction. So I don't want negative or positive here when they talk about impulse. See, some of you, why I'm telling this is if you have written the answer as minus also, it is okay as long as you have given justification with the help of a diagram in your answer sheet. Because according to you, according to someone, this might be the bat and this side would be the bowler. According to some of you, it might be the reverse. So depending on how you have drawn the diagram, the value of negative or positive will change. But what is the magnitude in this problem? So you should understand this also. It is very important because I get some questions, sir, how am I supposed to report the answer? You need to understand in this question, minus or plus sign is not important at all. So when they ask you calculate the impulse, they're only asking you the magnitude. So plus or minus is just an additional information you're giving. Okay. Second, what is the average force that you need to? So impulse is equal to force into time. So force will be equal to impulse by time. So what will be the answer? Those are online. Are you doing it?
Yes, sir.
So let's solve this problem. a cricket ball of mass 150 gram. So mass is 150 gram or 0.15 kilogram, moving with a velocity of 15 meter per second is brought to rest. So V initial is this value, V final is going to be 0. And how much time did it take? Delta T is equal to 0.05 seconds. Now, what are we supposed to calculate? We need to calculate the impulse. So for impulse, we have the formula of change in linear momentum. So for change in linear momentum, it is going to be m into V final minus m into V initial. Since I didn't take the directions here, so m into V final is going to be 0 minus mass of this object is 0.15 into what is going to be the initial velocity, it will be 15. So 15 into 15 is 2.225. So answer will come out to be minus 2.25 Newton second. So minus 2.25 Newton second. Okay. So it's minus 2.25 Newton second. The next question is, calculate the average force exerted by the player. So we know that impulse is equal to force, external force into delta T. So J divided by delta T is going to give us the impulse. So it is 2.25 divided by how much is the time? 0.05 is equal to the external force. So it is basically going to be 225 divided by 5, or how much is the answer going to be? 45. So it is going to be 45 Newton that is applied. All right, multiply with 100 and divide it with 100, 225 by 5. So it is going to be 45 Newton. Clear with this, right? Shall I proceed to the next one? Solve this. That part, how much is it over the? So what is the answer, guys? Don't do it in mind, do it in a paper. Do it. Solve it. Why are you integrating? Are you integrating? Okay, drawing it. Okay. So in this problem, what is missing in the first place? So can you calculate the velocity of it? How? Sorry? I don't know. How did you find it out? Displacement is 1 meter. Okay. Bounces back, but they didn't give us with what velocity it is going to bounce back, no? See, initially it is falling from a height of 1 meter and it is rebounding back to a height of 0.5 meter. So when it is traveling through a distance of 1 meter, how much is going to be the velocity it is going to attain? And with what velocity is it rebounding? That's what you need to calculate. How will you do it? It's very simple, no? It's very simple. Why are you thinking so much? What are we supposed to do? So when there is a downward motion, right? So here the question says there is a rubber ball of mass 50 gram that falls from a height of 1 meter. So it is falling from a height of 1 meter. After hitting the ground, it is rebounding to a height of 0.5 meter. So I'm taking the downward journey into consideration. When it comes to downward journey, can I apply the formula v square minus u square is equal to s? So what is v square? That's what we need to find. V square minus what is the initial velocity with which it is dropped? 0. So 0 square is equal to 2 into observe. So if you are going to take downward direction as positive, in this case, then you are allowed to take g, the acceleration as g itself. And what is going to be the displacement? It will be 1 meter. So v square is equal to 2 into, I'll take g as 10 for now. So it is going to be 20, which implies v is equal to 2 root 5 meter per second. So this is the initial velocity. Why am I calling this as initial velocity? Because this is the velocity attained by the particle just before it hits the ground. So impulse comes into picture only after the collision has taken place. So this is going to be the initial velocity. It's working 0.4. Okay. So I'll just change the values here. So coming from this step, you will write it as 2 into 9.8, which is going to be 19.6. So what is going to be the value of V? Square root of 19.6. How much is that? It will not work. If it is 196, it will be 14. It is 1.96, you would have got that answer. It is 119.6. Still be a disturbance. That is why I didn't take it. But anyways, again a correction. So V square is equal to 2 into 10, which is going to be 20. I'm taking the value of G to be 10 itself. So V will be equal to how much? 2 root of 5 meter per second. And this is going to be what velocity? This is going to be the initial velocity. Why am I calling it as initial velocity? Because this is the velocity attained before it collides to the ground. Right? The next question is, after it has collided with the ground, with what velocity is it going to rebound in upward direction? So now I need to calculate the final velocity. So for calculating the final velocity, I need to take the upward journey. So I need to take the upward journey. So I'll apply the formula of V square minus U square is equal to 2 into A into S. Right. So during the upward journey, after it has traveled to a distance of, half meter, that is 0.5 meter. what is going to be the velocity of that object at that point? So after it has traveled to maximum height, its velocity is going to be 0. So 0 square minus, listen to this carefully, the initial velocity with which the object is getting rebounded is going to be the final velocity after the collision. So this is what is going to be Vf square, because this is the velocity attained by the particle immediately after collision. So this is the velocity before the collision. There is the velocity after the collision. So this will be initial velocity. This will be final velocity. Am I clear till this point? Right. So minus Vf square is equal to 2 into, I'm taking the acceleration as 10. Now listen to this carefully. No, it is not negative, because for downward journey, I took downward things to be positive. So for upward journey, I'm taking upward to be positive. As I told you, I'm free to do so. So that is why I broke the problem into two parts. For downward, what did I consider? Any velocity, any vector quantity in the downward direction as positive. For upward, any vector in the upward direction is positive. Now, if you see, oh, you're right actually. Yeah, you're right. So acceleration is going to be negative, right? So here it is going to be minus 10. So 2 and 2 will get cancelled, but here you have a minus, no. So Vf square will be equal to 10. Minus Vf square is minus 10. So Vf square will be 10. So Vf will be equal to how much? Square root of 10 meter per second. Makes sense? Right. Now what do I have in my hand? I have the initial velocity and the final velocity. Now I can easily find the impulse. So what is going to be the formula for impulse? Impulse formula is delta P. So mass into final velocity minus mass into initial velocity. What is the final velocity? So what is the mass here? 50 gram. So 50 into 10 power minus 3 into, what is V final? Square root of 10 minus, what is the initial velocity? You should not write it as 2 root 5. You should write it as minus 2 root 5, because observe the situation. After the collision has taken place, final velocity is in this direction. So if you take upward as positive, then V initial was like this. So downward would have been negative. So that is why minus of minus is coming. So you need to be careful with these things. This is where I've seen most of the common mistakes that happen. Is the point clear? So this will be equal to 0.05 into square root of 10 plus 2 root 5. Okay. So this value, I'm leaving it to you to calculate. Once you calculate, that is going to give you the impulse. Right. Now, we need to find the average force. So for finding the average force, all that we need to do is, so for finding the average external force, what are we supposed to do? Impulse divided by delta T. So you have the impulse value here, take it and plug it here, divided by how much will come? 0.1. So when you calculate that, that will give you the answer. So whatever answer you're going to get, just push the value of decimal to 1 on the left. That will be the final answer, because it is 0. No. I'm sorry, correction. Push it to the right. So whatever value you get here, just push that value, just push the decimal value to right. See, for example, if you get 1.2 as the impulse, external force will be 12. Because it is 10 power minus 1, it will go to the numerator as 10 power 1. It will become into 10. Root 5 is 2.2 something. 2.25. And root 10 will be 3.2 approximately. Three point three plus 4.5. 7.7. 7.8. 78. Right. And solve this problem, listen to this. There's an important problem. Listen. There is a ball which is moving with a momentum of 5 kilogram meter per second, strikes against a wall at an angle of 45 degrees and is reflected at the same angle. Calculate the change in momentum. Okay. So what is happening here? A ball moving with a momentum of 5 kilogram meter per second strikes against a wall at an angle of 45 degree and is reflected at the same angle. Calculate the change in momentum. Right. If I take this to be the wall, right? If I take this to be the wall, there is a ball that is going and striking this surface at an angle of 45 degrees. Right. Actually, what will happen is here the angle will be this also you can take it as 45 degree because they didn't tell it with respect to normal or wall. Against a wall at an angle of 45 degrees. So I'm taking this to be 45. Since this is 45, this will also be 45. Right. In a similar way, it is rebounding with what velocity, with what angle? Same angle 45. So this will also be 45 to be an angular bisector. Right. Okay. Now the momentum of this ball is 5 kilogram meter per second. And it is going to rebound at the same angle. And here also, I'm going to take the momentum to be the same. So it is going to be 5 kilogram meter per second, because they didn't speak anything about the change in momentum. I mean, the value of the momentum to change from 5 to something else. I'm taking the same thing. And this type of a collision is called as elastic collision. Okay, about which we'll discuss in detail in the next chapter. So this is called as elastic collision or perfectly elastic collision. Is that clear? No. What do you think is the answer going to be? So here the momentum is 5 kilogram meter per second. Here also it is 5 kilogram meter per second. So what should the answer be? Change in momentum is final minus initial. So what should be the answer? It should be 0. But that's where the mistake is there again. One point we always forget. What is it? Momentum has direction. So if you observe, for the first case, the momentum direction is like this. And for the second case, the momentum direction is in this way. So what is happening is, unlike the previous problems where everything was confined only to one dimension, here there are 2 dimensions. That is the x-axis and the y-axis. You need to resolve it into 2 components. So this momentum, I'll draw a separate diagram. I'm talking about the journey towards the wall. Right, when I take the journey towards the wall, this momentum mv should be broken into 2 other parts. One is going to be along the horizontal. So how much can I take this angle to be? 45. So mv is here, angle is here. So what should this component be? So it will be mv cos 45 and this will be mv sin 45. Fortunately, you take 45 anywhere, it's going to give you the same answer. Because cos 45 and sin 45 are the same. What is the value of mv? It is 5. So it should be 5 by root 2 here, 5 by root 2 downward, and this direction should have the value of 5. I hope you are able to understand. This is the journey towards wall. So what about the journey away from the wall? So what about the journey away from the wall? If you observe, this is the way, this is the direction of the momentum. So which is going to be 5. Now if I drop a perpendicular from here, this is 45. So here itself, I can resolve it into 2 components. This is going to be 45. So this will be 45. Same, right? So this will be 5 cos 45 and this will be 5 sin 45. So how much will be the answer in the leftward direction? It will be 5 by root 2 here, and here it will be 5 by root 2. And how much is the answer here going to be? It will be 5 itself. Is the point clear? The same values are appearing, but the only difference is direction. So when it is towards the wall, observe the x component here. The x component, when it is towards the wall, is to the right, whereas when it is away from the wall, it is to the left. But what is happening to the y component? In both the cases, it is in the downward direction only. So when they ask to calculate the change in momentum in this case, you need to calculate for x separately, you need to calculate it for y separately, and then you need to take the resultant of it. Okay. So what is the change in momentum taking place along the x direction? It is going to be P final along x direction minus the P initial along x direction. So what is the P final along x direction? So P final along x direction is going to be minus 5 by root 2 minus, what is going to be the P initial along x direction? Minus 5 by root 2. So it will be minus 10 by root 2. Or it will be minus 10 root 2 by 2, which is minus 5 root 2. So the change in momentum along x direction is going to be minus 5 root 2. The meaning of minus is it is taking place in this direction. Okay. Similarly, what is going to be the change in momentum along y direction? It is the P final along y direction minus P initial along y direction. What is the P final along y direction? It is 5 by root 2 minus what is the P initial along x direction? That is also 5 by root 2. Hence, the answer will be 0. Means in this case, what is happening is the change in momentum is taking place only along x direction. There is nothing along y direction. Is the point clear? So that is how it works, right? So this is your textbook problem also. So please make a note of it and mark it as important. Those who are online, could you understand?
Yes, sir. Yes.
Okay. Is there any test going in your school? Is there any test going in your school? Where are these people? They come to school? You had school to you didn't go. Irkada textbook in the problem. Example nanikiram. It's an example problem. Revised book illa nani. Revised book ada. Clear, better. Just pass the book. Actually, it is see 5.5.20 page 111. Exercise questions. There is what they have done is they have converted this into a problem saying there is a batsman that deflects a ball by an angle of 45 degrees without changing its initial speed, which is equal to 54 kilometers per hour. What is the impulse imparted to the ball? So here they have directly given you the momentum. But I hope you could understand, no? Right? See, we have the Indra na Okay, so I hope you could understand this, no? As I told you, mark this as important, and there is an example. I don't know what is the example number in new book. Can you tell me? Hallelujah. 5.5 கொடுத்திருக்கீங்க. இருக்கா? 5.5 அது page number 4.5. Yeah, first chapter is 57. So in page number 57 in example 4.5 is a similar kind of problem. You can try that out. Okay. See, with this, no, actually we have completed the first part of this chapter. The second part is about friction and its applications. So I would need 3 more classes, and just want to give you a heads up. This chapter, the next chapter, and the subsequent chapter all can be learned only with these kind of problems, because these are considered to be some of the tough chapters. So I'm trying to do as many problems as possible. Apart from that, you also practice from the study material that is given to you. So under the subtopic, there will be problems under that. Just work from it. Is that clear? So next class, I'll start friction. So before the math class, you can take 5 minutes break. Just take a break. Those are online also, you can take a break. Let's start the class around 6:20.
Okay, sir.